Let's start by adding a new class. We call it heap. In this heap, we need an integer array to store our items. So let's call it items and initialize it to an array of 10 items. Now we could also create a constructor and pass the initial capacity here, but I don't want to spend time on this because we already covered this before. We also need a field for keeping track of the number of items in our heap, because later when we implement the remove operation, we're simply going to decrease the value of the size field. We're not going to physically remove our items from the array. Okay? Now let's implement the insert method. So insert, we give it a value. Here we should store this value in the next available slot. So we set items of size to this new value. And then we should also increment the size field. So this is how we store this new item in the next available slot. Now we should implement the bubble up operation. So if this new item is greater than its parent, that means we should bubble up this item until it's in the right position. So what is the index of this new item? That is going to be size minus 1, because we just incremented the size field by 1. So the index of the last item is size minus 1. Now, as long as the item at this index is greater than its parent, so here we need to calculate the index of the parent. That is very easy. We set parent index to index minus 1 divided by 2. So if this item is greater than the item at the parent index, we need to swap these items. So I'm going to implement the swapping in a separate method, because otherwise our insert method would get a little bit bulky. So let's declare a private method, private void swap. We give it 2 indexes, first and second. Now, how can we swap 2 variables? I believe we have done this before. It's pretty easy. We declare a temp variable and copy the first item into this temp variable. So items of first goes here. Then we copy the second item into the first item. So items of first, we set this to items of second. And finally, whatever we have in this temp variable, we're going to copy it at this location. So items of second equals temp. Now, back to our insert method. If this item is greater than its parent, we need to swap them. So we swap the items at this index and at this parent index. Now we need to set the index to the parent index. For example, if in our tree we have, let's say 50, then we have 40, and now we add 60. So in the first iteration, we're going to swap the 60 with the 40. So 60 is going to be here and 40 is going to come down. But we're not going to stop here. As long as this item is greater than its parent, we have to bubble it up. So before the second iteration, we need to reset the index. Initially, the index was pointing at this node. Now it should point at its parent node. So we set index to, here we have to recalculate the index. So whatever index we have, we subtract it by 1 and then divide it by 2. Now, as you can see, we have repeated this logic in a couple of places. So it's better to extract this and put it in a separate private method. So let me delete these comments. Here we declare a private method that returns an integer. We call it parent and give it an index. And here we return index minus 1 divided by 2. Okay? Now we're going to reuse this in our insert method. So first, I'm going to get rid of this variable. In our loop condition, I'm going to calculate the index of the parent dynamically. So here we call parent and give it this index. This is very important because in each iteration, the index changes. So we should recalculate the index of the parent. Now on line 12, we're also going to replace this with parent of index. And finally on line 13, we set the index to its parent. Now, as we bubble up a value in this tree, the index is essentially being decreased. It's getting smaller and smaller. So at some point, it is possible that it will become a negative number and it will fall outside of our array. So we should guard this while loop with another condition. While index is greater than 0 and this item is greater than its parent, we're going to continue bubbling up. Now you might ask why I didn't use greater than or equal to here. Because if the index is 0, its parent is going to be 0 minus 1 divided by 2. It's going to be a negative number. So the index should always be greater than 0. Okay? Now, this is our bubbling up algorithm. I would prefer to extract this into a separate method and make our code more expressive and cleaner. So let's declare a private method, private void bubble up. Now, we select these few lines and move them down into this new method. And finally, we call this method in our insert method. So each method is short and sweet. It's doing only a single thing, and our code is basically telling a story. This is what we call beautiful code. Now, one last thing. As we insert new items, our array may get full. So we need to check for that at the beginning of this method. If the number of items we have equals the maximum capacity of this array, we're going to throw a new illegal state exception. We could also extract this logic into a separate method and make our code more expressive. So I'm going to make this method public because we might use it from outside of this class. Public boolean is full. And here we return this expression, size equals items.length. Finally, we replace this expression with a call to this new method. Much better. Now let's test our implementation. So back to the main class, I'm going to create a heap and insert a bunch of items in it. So let's say 10, then 5, then 17. Now 17 is going to be the right child of the 10, and because it's greater than the 10, our heap should bubble it up. Let's take a look. So I'm going to do a print line here, then insert a breakpoint on this line, and run this program using the debugger. Now let's inspect our heap. So we have 17, 5, and 10. So 17 is going to be the root node, 5 is going to be the left child, and 10 is going to be the right child. Because in the tree we have 0, 1, 2, 3, 4, 5, and so on. Now let's add a couple more items. So I'm going to add 4. This is going to end up as the left child of the 5. So it's not going to violate the heap property. But let's add 22. This is going to be the right child of the 5. So it's going to get bubbled up, and eventually it's going to be the root of our tree. Take a look. So 22 is at the root. Then we have 17 on the left and 10 on the right. 4 and 5 are going to be the children of 17. So our heap is working properly. Next, we're going to implement the remove operation.